As I have been telling you from my previous lectures about the basic data structures, till now we have learnt about arrays, then we have learnt about stacks, queues, linked lists, and trees also. But we are just having a brief idea, a very brief, very cryptic idea about these data structures. Later on we will be delving deep into all these topics. So now in this lecture I am going to tell you about graphs. A very brief description of graphs I am going to give you. Now see, first thing you will have to know is a graph is a non-linear data structure. It's not a linear data structure like arrays and linked lists. So graphs, they can be categorized into two categories. The first one is directed graphs, which is also called digraph, and another one is undirected graphs. So let me tell you with the help of an example. Rather, I will be taking two examples. This is an example of undirected graph. In this kind of graph, you can see these are the nodes A, B, C, D, E, F, or they are also called vertices. Singular is vertex, plural is vertices. So these are the nodes which are containing some information, and as you can see, all these nodes, they are joined together, and you can clearly see it's not a linear structure, it's just a non-linear structure. So as we can see, there is a node A which is connected with node B, or you can say vertex, and there is a node C which is connected with B, but there is no path in this. How we can distinguish between an undirected graph and directed graph is, in case of undirected graphs, there is no path. Like we cannot say whether the flow is from A to B or B to A, because there is no pointer, there is no arrow mark. So in the next example, I'm going to show you directed graph, which is also called digraph. In this case, you can see that there is a path being shown from A to B, and here as far as B and C are concerned, you can see a path from C to B and not from B to C. Similarly, you can see a path from C to D. You can see a path from moving towards D, from E to D. Similarly, you can see a path emanating from F and going till E. So as I have told you in the previous slide, that these all A, B, C, D, E, they are nodes, or they are called vertices. So A, B, C, D, E, F, all these are nodes, and there is a thing called edges. Now, because the path is from A to B, I would say AB is the edge. BA is not the edge in this example, because the arrow is from A towards B. Similarly, you can see that there is no edge BC. Why? Because the path is moving from C to B, so that you can see the arrow. So hence we can say that the edge is CB and not BC. Similarly, now you can see for yourself that CD is also an edge, ED, because the path is from E to D. So ED is an edge. Similarly, FE is an edge, AF is an edge, and not FE. Why? Because the path is from A to F. And similarly, lastly, you can see BE is an edge, not EB, because path is from B to E. So this was a very short description of graphs, and later on, as I have been telling you repeatedly, that we will be dealing with these topics in detail in our subsequent lectures.